Sure. Hi guys, Miss Jeter and I are here today to do an experiment to help you understand chemical reactions. So we have some distilled vinegar, which is just vinegar that you buy at the grocery store, and we put it in a beaker. And so as we are doing the experiment, you're going to be filling out this lab sheet. And so you have this on your computer, and we'll tell you when to stop and when to fill out. All right, so first I guess we should describe this. Why don't you describe what that First of all, what is it? I didn't even tell them what it was.
I want you to get a really good look at this, okay? This is steel wool. You might have some of this around your house. A lot of times we use it for scrubbing things, maybe getting the paint off furniture. It's very, very rough. And that's one of the reasons that Miss Sluss and I are wearing gloves today. It's very, very rough. It scratches a lot. It's steel that has been spun into really, really fine threads, fine wires. And when you are looking at it, those wires are a little bit sharp. It's a little bit, it could hurt your hands a little bit, so you got to be careful with it.
You need to think about that this is a mixture, right, of carbon and iron, and that this is put into wires, just like we've been talking about with ductility.
So pretty cool. Okay, so we have described it. So on your paper, remember you need to split your screen. On your paper, go to number 1 on the procedure and write down how the element iron looks. How does the steel wool look like? That's kind of a gray color. If you couldn't see it very well on the video, that's another good thing that you could write down there. Very much like metals are, like we talked about on the periodic table.
All right, we're back. So now what we're going to do, this is step number 2, is we're going to place this steel wool into this beaker. Miss Jeter put the vinegar, which is acetic acid, into this beaker. And so we're just going to drop it in. Steel wool has a coating on it that protects it from oxygen. And so we need to get rid of that so that we can see a reaction. So we're going to put that inside there.
And I'm going to pour some more in.
Yeah,
we're going to load this baby up. Okay.
So there's the vinegar. This isn't even the reaction we're interested in. We just have to do this to get rid of the coating that's on the steel wool. So that takes a minute. So we're going to stop the video, and then we're going to wait 1 minute.
See you in a minute, guys. All right, guys, we are back, and we have let the vinegar sit for about a minute with the steel wool in it. And if you'll notice on your lab sheet, it says that to use gloves, we have to take the steel wool out. So I'm taking it out of the vinegar, letting it drain a little bit. And then I'm going to kind of squeeze a little bit of it out. So I'm going to set that vinegar off to the side. And now we get to use a thermometer. And we are going to wrap the steel wool around the thermometer and maybe right around the bulb. Okay. And then we're going to tie it off and make it sure it's really, really secure with a rubber band. Now this is a little tricky because this wool is slippery and spiky. But guys, right now, when you take a look, see the steel wool is still gray. Keep that in mind, okay? And we're going to let it sit with the steel wool around the thermometer.
Let's get our temperature before it gets in there.
That's a good idea. Okay.
So we are at 29 degrees Celsius. 29 degrees Celsius, which feels a little warm for me, Miss Jeter.
Yeah, it does. It does. We need to record that temperature on number 3 on your lab sheet. So make sure that you go back and look at that.
Now we're going to cover it with aluminum foil. So you remember, one of the signs of a chemical reaction can be a temperature change. So we want to see if there is going to be a temperature change, we can kind of hold it in there.
Okay. We have to wait for 5 minutes. So we will come back in 5 minutes and we're going to make some observations. We're going to look not only at the temperature of the thermometer, but we're also going to look at the steel wool itself to see maybe is there a color change? Does it have a different odor? Remember, all those different signs of chemical changes are what we're going to be looking for here. Okay, guys. Welcome back, guys. We have waited 5 minutes, And now we are ready to make our observation. So we are on step number 6 on your lab sheet, if you are keeping up with that. So let's take a look at the beaker. Miss Sluss noticed this, and I thought this was a really cool observation. See how cloudy it is? See how much condensation there is on the inside? So the temperature has obviously changed even just by looking at the beaker. So let's take out the...
Does it feel hot?
Oh, Miss Sluss,
Yes, it is.
let's take a look.
Let's see what the temperature. Ooh, look at that.
All right, the temperature is now what, Miss Sluss?
So now we are at a balmy, let's say 32.
There we
Let's say
go.
32.
So how much has the temperature increased, guys? By 2 degrees, right? All right, now let's take a look at the steel wool itself. Is it still the same color? What do you think, Miss Sluss?
It definitely looks brown. It's definitely brown. Do you think that they can see that on there?
Let's get a little bit closer.
And you can tell the difference when you find places where there's still kind of a silver color. And we'll show you steel wool in class and show you what it looks like.
Let's take a look. Let's get some of these rubber bands kind of pulled off here. Good thing we're wearing our gloves.
Yeah, I've only got the one on. So.
Oh, okay. All right.
So there you go. It is almost completely
oh my
brown
goodness, look at that.
throughout.
Wow. So, guys, on your lab sheet, let's take a look.
This is number 6.
How does the iron look now after sitting in vinegar? Has there been a color change? And Miss Sluss, did it feel a little bit warmer to you on the outside?
It definitely does.
Yeah. Very cool, very cool. Okay, so down underneath number 6, it says iron has 2 valence electrons. Oxygen out in the air in the room has 6 valence electrons. So are these, let's make a prediction, are these elements going to be reactive based on how many valence electrons? Think about it. Do they have the 8 in the outer shell? Okay. All right. Let's look at the event on your paper. Okay.
So what happened to the temperature and the appearance of the steel wool?
Okay. So write down what happened to the temperature, what happened to the appearance. Okay.
So you're writing that in your lab sheet, and you can push pause if you need to.
Then claim. Our claim is a chemical reaction did or did not occur. So you need to decide which one of those that is and write that in. Either did or did not occur.
And then we need some evidence. The next part, we're going to need some evidence. So how would you know that a chemical reaction occurs? So you made your claim, and now this paper has 3 things that tell us there was a chemical reaction. So you want to come up with those 3 things.
Okay. And then after you have finished that, you can write in your reasoning. What did you observe? A chemical reaction occurred because what did you observe? Tell us about one of those 3 things that you saw, and think about the videos that you've seen, the Nearpods that you've done. In a chemical reaction, what kinds of things happen? Do you have color changes, temperature changes? Lots of different things can happen. Okay, guys. Have a great day.